Okay, now we are going to learn the concept for beta angle problems in plane surfaces. Okay, so how to identify a particular problem is beta angle or not. Okay, so you can see in this if any one of the angle of inclination with respect to HP or VP, any one of the angle of inclination. So you can take either the inclination to the HP or VP if it is there with. You can see these words are important: median for triangle, diagonal for square, perpendicular bisector for pentagon, and diagonal for circle, and diameter for circle. Okay, diameter for circle, if it is given, then it is called as beta angle problem. You can see in these diagrams, for a triangle, a line drawn from this corner point to the exactly middle of the this side, we calling that is a median. Okay, for triangular type of problem, he will be mentioning a word called median. Okay, similarly, for a square problem, he'll be mentioning a word called diagonal. Okay, diagonal will be there connecting the corner 2 points. So he will be mentioning that. So that is indicating that it is in beta angle. Similarly, for pentagon, we have perpendicular bisector. If this word is mentioned, means it is an beta angle. Similarly, for hexagon, they will be mentioning a word called diagonal. Okay, if that particular word is defined, means it's an beta angle. Similarly, for the circle, you can see this circle. So there will be a diameter given. The angle of inclination will be given with respect to diameter, any one of the angle of inclination. Okay, either with respect to HP or with respect to the VP. So that's how we can identify it is an beta angle problem. So remember it, any one of the inclination either to the HP plane or to the VP plane, if it is mentioned with respect to median for triangle, diagonal for square, perpendicular bisector for pentagon, diagonal for hexagon, and diameter for circle given, then it is an beta angle problem. Okay, in beta angle problem, you see this, the first two positions will be remaining same. So that's why I've drawn the first two positions here. You can see equilateral triangular lamina of dimension 25 lies on one of its sides on HP. So we have constructed the first position top and front view. Next, the lamina makes 45 degree with HP. So 45 degree inclination also we have shown here. Now you see the only change with respect to normal type problem and this beta angle is, so it is changed only with respect to the third position. So first two positions will be remaining same. That's why I have drawn initially these two positions. Now we have to construct the third position. So that is one of its median is inclined at 40 degree to VP. That is, so you can see here the median it is given for an equilateral triangle. So it is an beta angle problem. So what is the procedure here? So please you follow it. First I'll marking a reference point, and then keeping at this reference point, I'll be marking at 40 degree because angle of inclination to VP it is 40 degree. So I'll be drawing an angle line here. Okay, so this is having angle of inclination 40. So after this drawing angle of inclination, what we have to do is we have to draw the medians here. Okay, median length. So median length it is starting from this point to here, horizontal line. So this is BD1. Okay, now similarly we have second median length, that is we have second median length from here to here. Okay, that's what the second median length. So this is BT. So we have two median lengths. Initially what we do, we mark a point of B here. First we are going to measure this first median length, this is second median length. Okay, there are two medians, one is BD1 and second one is BT. First we have to use this BT1. Okay, using the compass we are going to measure this length. Okay, we are going to measure this length. Now I'm going to cut the arc. Okay, so this is BT1. Okay, after cutting the arc, what we have to do is, using the scale we have to draw locus of line. Locus line we have to draw here. Okay, we have to draw a locus, so we call it as locus of D. So we have to draw a locus line. So after that what we have to do, so we have to measure this length, that is from B to D. So measuring from B to D, you can cut the arc. So somewhere here you can get the arc. Okay, So after cutting the arc, so you have to join this point. Okay, you have to join this touch point, and then you can extend this. Okay, you can extend this, so the angle you can get, so that is nothing but beta angle. Okay, this is BD. Okay, BD. Now we are going to measure how much the angle we have to get here. So here okay, we have to join it here. Okay, some mistake happened here. So you can see here, 1 minute. So we have to measure exactly the length. Okay, so from BD, so cut the arc. So exactly it is cutted here. Okay, so joining of these 2 points is very important. Okay, then you can extend this line. Okay, extend this line. So this is where it is very important. Now you find out how much angle it is. So this is BD. Okay, so angle here I am getting around 70 degree. Okay, so you need to get 71 degree, but if you're getting 1 or 2 degree variation, that will be okay. So we get the BD length. Now we have to transfer this diagram over here, correct? So we have to transfer the diagram over here. So what I will do here initially, so with respect to this line, BD line, I am going to merge this 90 degree line. Okay, merge this 90 degree line. Okay, merge this 90 degree line and draw a straight line here. Okay, straight horizontal line. Okay, so after this, by cutting the arcs, okay, we have to transfer this diagram. So this diagram we have to copy. Okay, that is BD. Okay, BD, sorry, BC and BD. This will be having the same length. Okay, so here at this point we get it. This is BC and this is BA. Okay, so now what we do, so we have to join this. Okay, so this is our okay, so understood. Now we have to project it upward from B, from C, from this A point. Okay, so where they are merging, we have to see it. A, it is merging here, it is A dash. C, it is merging here, it is C dash. And similarly B, so it is merging here, B dash. So now we have to connect this. Okay, so this is what the problem. So you understood the procedure, right? So after constructing these two positions, we have to draw the median, that is BD1 first median and BD. So this is the first median, this is the second median. So we draw 40 degree angle line. After that we mark a point B. So first we will measure BD1, this median length, and we cut the arc. After we getting the arc on this 40 degree angle line, we will be drawing a locus. So we mention it is locus of D. Okay, we mention it is locus of D. So after that what we do, we measure again from B to D. We measuring from B to D, we will be cutting the arc on this locus line. So there is a locus line here, right? So on this locus line we are cutted the arc. After cutting the arc, we are going to join BD. Okay, after cutting the arc we join BD, and then we are going to extend this BD line using a scale till it is touches the XY line. Okay, after that we are going to find out angle. This is what your beta angle. Okay, beta angle 70 degree, around 71 degree you have to get. If it is 1 or 2 degree variation, there is no problem. Okay, so after that same procedure, by extending from C, from B, from BA, we'll get the final diagram. Understood, right? First two positions remain same as it is with the normal problem, but in the third position we see the changes. Okay, first we have to use the first median length, second median length. After that we have to find out the beta angle, then transfer this diagram using arc method, then finish the final position. So we learn another problem on a square plate lamina with respect to the beta angle. Okay, we will proceed with the question. So in this question, a square plate of 30 mm side, we need to construct a square of 30 mm side, rests on HP. So the first position starts from the HP plane, such that one of the diagonals is inclined at 30 degree. So you can see that one of the diagonals they have mentioned. So one of the diagonals for a square means it is an beta angle problem, right? So one of the diagonals they have mentioned means it is an beta angle problem. So is inclined at 30 degree to HP and 45 degree to VP. So you can see in this question they have not mentioned either it is resting with the on the HP plane with respect to edge or corner. So we need to find out, okay, is it resting with the edge or with the corner. So is he mentioning that the angle of inclination will be there with respect to the diagonal here. Okay, so how we are going to find out? So the angle of inclination are there with respect to the first position, it is there with respect to the edge or with respect to the corner, because you can see, say consider this is one of the square, so which is connected with the diagonal. Okay, because here in the angle of inclinations were given, say like this angle of inclination to HP and an angle of inclination to VP. Okay, so what we do, you can see here. So I'll be taking a particular book here, so you can understand easily. So you can consider this is this only. Okay, so say angle of inclinations will be there with respect to this diagonal here like this. So you can see in this, so the angle of inclination if it is there with the diagonal means your first position has to be a corner here. Okay, first position has to be corner, because so angle of inclination if it is there with the diagonal, then you can see that the first position will be there with respect to the corner only. Okay, so here both the inclinations will be there with respect to the diagonal. You can see that one of the diagonal is inclined at 30 degree to HP and 45 degree to VP. So for that I'll just drawing a rough sketch. So if say if our first position, okay, just for our trial, okay, trial 1, say we have been drawn a square with respect to edge. So what will be the conclusion? Say first position it is, if it is with the edge means what happens? So the second position, so in second position we are not able to incline it with the diagonal. So diagonal, say if it is there here, okay, so we are not able to incline it with the diagonal in the second position. So this one is wrong. Okay, this one is wrong. So let's say trial 2, say we have been positioned square like this. Okay, this is just a rough sketch. Say with the corner. So this is our diagonal. Okay, diagonal. So we can incline it in the second position. Okay, with the diagonal like this. Okay, so we can incline it. Say we have been placed the square lamina like this. Next first position. So in second position we can incline it. Okay, with respect to the corner point, with respect to the diagonal like this. Okay, there are two ends which is connected with the diagonals. So that means our first position starts from the corner point here. Okay, this is how we have to analyze it. Okay, so I'm going to construct a square with respect to corner here. So understood, right? The two trials we have done. So one trial with the edge. So in the second position we are not able to do it with the diagonal in case if it is started with the edge. Say if we have started with the corner means we can able to give the inclination in the second position also and in the third position also. Okay, so how to draw the square with respect to corner means as we have learned. Okay, so what is the first, I'll be marking a reference point here. So that is what the reference point. Okay, to the reference point, so using a protractor we know the procedure. So we have to mark for 45 degree, correct? So exactly 45 degree we can mark here. So I have marked for 45 degree. So I'll be drawing an line here passing from this reference point to this. Okay, okay, now after this what we have to do, we have to measure 30 mm because a square of dimension 30. So measure 30 mm from the compass. using a scale. Okay, so 30 we have measured, so we can cut the arc here, two arcs. So after cutting the arcs from this end, so you have to cut another arcs. Okay, okay, it is cutting here. Okay, it is wrong, so you can take little bit downward. Okay, so because in order to construct it correctly, so we take the reference point a little bit lower here, such that it should not merge. Okay, so we can mark again 45°. No need to worry. Okay, so we have drawn it. Now using the compass, we have measured 30 mm, right? Already measured it. Again we can measure it again. So it is 30. So cut the arcs. Again second arc from here. Okay, so you can join this. So this is what the square of dimension 30 will show the dimension on one side. This is 30. Now we can mark the namings A, B, C and D. So now we'll project to complete the first position front view. So we are able to see A dash, B dash, C dash, but D dash not visible here. Okay, now the second position. So first two positions will be same, 30° to HP. Okay, second position, so I'll mark A dash. I'll be marking at 30°. So mark at 30°. Okay, so it is 30°. We have to cut the two arcs here. Okay, first arc from this A dash to C dash, first arc. Second arc from A dash to B dash. So we can mark the naming B dash, D dash, and this is C dash. Okay, from this A to C dash we have marked the length, and we can erase the remaining part. Now we will be projecting downward. Okay, okay. Now we can mark the namings A, B, C, this is D. So we can join this. So this is what the first two positions. So first two positions will be remaining same. Now we have to draw an diagonal line here. First we will draw for the first position diagram. Okay, so this is I'll be marking AC1, and this one it is AC. So we will not mark with the other name, the same name, but we will change it to AC1. So this is your first diagonal line, and this is your second diagonal line. Now, so we have to draw the 45° angle line. Okay, 45° angle line we have to draw. I'll be drawing an angle here, taking a reference point here. So So mark for 45. This is 45 we have drawn. Now first I'll be marking a point, reference point here. Same procedure. Mark point A. Now we have to use this first diagonal length. Okay, AC1. Okay, AC1 we have to measure. Okay, AC1 length I have measured, and I'm cutting the arc. This is AC1. So after this you can draw an locus line here, calling that locus of C1. Okay, locus of C. Okay, this is locus of C. Now the second arc length from A to C, measuring from A to C, cut another arc. So this point is C. So now we join this. This is where the point is joined, then extend. Okay, and then you find out this angle. So this angle, it is your beta angle. So here the angle I am getting, it is around 55, 56, 57 degrees. Okay, so 57 degree is my beta angle. Okay, now you see that this diagram we have to copy. Okay, this already we have drawn AC, so we have to construct this diagram here. So we already have AC, so we have to construct from A to D. Okay, this A to D, it is exactly equal to C to D. Okay, just say A to D length, it is exactly equal to C to D, and similarly this C to B, it is same. Okay, so these two lengths are same. Okay, in a vice versa case, so you can connect it. So now you can mark this. So this point is D, this point is B. Now you join this. Okay. So this is we have done. Now we have to project upward to complete the final position. So now we have to complete the final position. You see where A is merging. So this is A dash. Similarly we have, this is B dash. So this point is C dash, and this point is D dash. Now we will join these points to get the final position here. Okay, so this is what the final position. So today we are going to learn beta angle problem related to the pentagonal lamina. Okay, so in this problem you see it, pentagonal lamina of dimension 25, so placed on one of its corners and HP. So we know that in a pentagonal problem also first two positions will be remain same, so that's why I drawn the two positions. You can see that pentagonal lamina of dimension, so resting on HP with one of its corners. On the left hand side I have drawn the first position, and then inclination to HP it is given 30 degree, so that I have drawn. Now we have to proceed with the beta angle, because they have mentioned a word called perpendicular bisector. Okay, so for that first I'll be drawing an angle line. Okay, so angle line I'm so 45 degree. So now we have to draw the perpendicular bisector, say from this corner point to exactly the middle point. Okay, this is M1. So first I will be taking a reference point of A, AM1. So this is locus of M. So this is the angle that is nothing but beta angle. So we have to find out this. So angle here we get it is around 55 degree. Okay, so now we have initially now from C to B, next D to E. So these two lengths will be same. Now we have to cut the reverse here, A to B. Okay, so this is B and this is E. Okay. Okay, now we will be extending this to get the final weave. Okay. Okay, now this is A dash. So B dash we get this is, C dash will get this, and D dash we are going to get here, and E dash will be getting here. Okay, now we have to join these points. Okay. This is how we complete the beta angle in pentagon. Now we will solve the hexagonal problem on a beta angle. So first two positions are already drawn. Now we will proceed with the beta angle. You just see the question: a hexagonal lamina of dimension 25 rests on one of its own corners on HP. So we have drawn the first position. The lamina makes 45 degree to HP. So we have drawn the second position. You see it. Now you can see the question in the they mentioned diagonal passing through the corner that is inclined to 30 degree to VP. So now we are going to show how the beta angle here. Okay. So before for that we'll be drawing a diagonal here. Okay, this is what the first diagonal, and this is our second diagonal. So I will be writing this FC1 and this is FC. Now I'm drawing in. First I'll take a reference point here, reference point. Okay, and now I'll be marking at an angle of 30. So that's what the inclination to 30 degree. Okay, so now I'll be taking a reference of okay, a reference here f I have taken. Now first arc, so this is what the first diagonal line we have to consider, this is what the second. So first we have to consider FC1. Okay, you know, with the bit angle concept, first this length we have to consider FC1. We are cutting the arc. Okay, so after cutting the arc, so to this point, exactly to this point we have to draw an locus. Okay, so this is locus of, this is C1, locus of C. Okay, after this the second arc length we have to cut, that is this one, FC. Okay, FC we have to measure and we have to cut on this locus line. This is your FC. Okay, now we have to join this FC line and then extend it. Okay, extend it to get the beta angle. So how much beta angle we will get it here? So we have to get so we are getting it around 44 or 45 degree, so it will be okay, no problem. We have this length. Now we have to transfer this diagram over here. We have the FC length. Okay, so first I'll be measuring this FE. So this FE length, okay, see this FE length is exactly equal to your FA. Okay, so we can cut two arcs here and here. Okay, two arcs. Similarly we have FD. This FD is exactly equal to this FE length, sorry, CD and CB. So four arcs we have cut. Now the reverse, one arc length, it is exactly equal to C FD, it is exactly equal to your FB. Similarly, so this FD FB is exactly equal to FE and FA. So that means measuring one length we can cut the four arcs. Okay, here this arc and this arc. So now this arc is not cutting, so this is FE. Okay, so now understood, right? The initial arc from FE is equal to FA, so that is exactly equal to CD and CB. Four arcs we have cut it. Then after that reverse we have cut it, that is FD exactly equal to FB. Similarly FB exactly equal to CE and CB. That's what we cut it. 1, 2, 3 and 4. So after cutting the arcs we have to name it. So this is E, this is D, this is A, this is B. So now we'll join this. Okay, so now we have to extend this. Yep. So A and A dash, so it is merging here. Okay, similarly we will see for B, so where the B is, so here we have the B. Okay, so initially we have marked for A dash, this is B dash. Similarly series C, this is C dash. Similarly we have
You have to tell the but you then
D
cannot
dash
tell anything from the five
FV.
that's why madam, so the next madam also told like that. So some network problem is there. You have to come from the network place. So after that, I will for every class I will ask the students. So if you have any doubt, if any network issue, you have to ask them. But they
So
told
now
me
we will
that
join
no
it.
sir, clear. Okay. Yeah, madam. I already told you that today I will share with you. Okay. Okay, thank you.
So this is what the final position. So understood, right? So first diagonal length will be cut at FC1, then locus line, then FC. So you have to cut the arc, then connect, and then extend. You get the beta angle. Then transfer the diagram using arc method. Then the final position.